Okay, we are in section 2 of unit 8 today, covering introduction to logarithms and converting between forms. So we're going to start with what a logarithm is. A logarithm, also known as log, is another way of writing exponents. It is the inverse of the exponential function. Its graph is the reflection of its related exponential function over the line y equals x. So a log is a mathematical expression used to answer the question, how many times must one base number be multiplied by itself to get another particular number? So for example, how many times does a base of 10 need to be multiplied by itself to get 1,000? And the answer would be 3, so the log of 1,000 is equal to 3. Or in other words, 10 to the third power is equal to 1,000. So it's still exponents, but it looks a little different. So log to exponential form, so another way of writing exponents, the logarithmic form would be f of x is equal to log base b of a is equal to x. Then exponential form would be b to the power of x is equal to a, and we don't actually need this f of x part. Sorry about that. I'm just used to writing it. Logarithmic forms, we read this as log base b of a is equal to x.
Log base 1 of 3.
So if we did log of 1, sorry, did you say of base 1? Okay, base 1 of 3, and then you gave us 5. But we'll see if that actually makes sense, because exponential form would be 1 to the power of 5 equals 3. So is that a true statement? No. So that does not actually work. Those aren't equal. But that does give you kind of where the numbers would go. All right. So just to kind of help remember this format, BAP the log. So we're going to rewrite this. Log, this would be base, A would be answer, equals, normally we'd put x there, but P, which would be the power. This isn't in your notes. This is just additional that I'm putting up here. If you want to write a note for yourself, you can. So log base of answer equals power. So BAP, B-A-P in log form, that's the order it goes. But then in an exponent, the base, B, of the power, P, is equal to the answer, A. So BAP is the log form order. Base, answer, power. Exponential, base of the power is equal to the answer. All right, so example 1, we're going to convert each log to exponential form. We have log base 7 of 1 is equal to 0. So then this is your base. This is your answer. And this is the power.
Will these always be true?
They should always be true. This is actually quite easy. So we have 7 to the power of 0 is equal to 1. That would be your exponential form. So then
7 to the power of 0.
7 to the power of 0 is 1. Anything to the power of 0 is 1. So this one, we have base of 2. The exponent is what? 4. Equal to the answer, 16. So what would this one be?
4 to the negative second.
Correct. All right. What about this one?
G to the power of 3.5 equals 7.
Good. So example 2, Now we're going the other way around. So remember, we have the base, we have the power, and we have the answer. So we have log base 12 of answer 12 is equal to the power 1.
Log 12
Which, by the way, the parentheses are not really super necessary. It's sometimes written without it, sometimes written with it. I prefer to write with the parentheses because it helps keep it separate from the base. But if you don't want to put the parentheses there, that's fine. Then part B, we have log base 36 of the answer 6 is equal to the power 1/2. So then on C, log base what? 2 of the answer 1/8 is equal to -3. There we go. All right. When we're evaluating logarithms, a logarithm with base 10 is called a common logarithm or a common log, and can be written without the base. So log base 10 of x is just log of x. So if there isn't a base written, it's automatically 10. Yep, base 10.
What do you mean it's automatically?
Because it's the common one.
Like gravity.
Example 3, we're going to use our knowledge of exponents to evaluate each of these logs. So this would be like log base 7 of 49 is equal to x. So then we have 7 to the power of x is equal to 49. What does x have to equal? 2. Because 7 squared is equal to 49. So then part B, we have 3 to the power of the unknown is equal to 27. 3 to the power of 3 is equal to 27, so x is equal to 3. Log base what? 10. So 10 to the power of x is equal to 100, which means x must be equal to 2 because 10 squared is equal to 100. All right. So then this one would be 12 to the power of x is equal to 1. 0 is the only number that we can plug in here. That 12 can be raised to that power to equal 1. So x has to be 0. The next thing we have is called the change of base formula. The change of base formula is helpful because sometimes the bases that we have are not easy to evaluate with. So we can change this by saying that the log base b of a is equal to the log of a over the log of b. So that's going to convert them to being both base 10. Yeah.
So like, our calculators have
Mm-hmm.
what does that do?
So the log button calculates, so like if we have log of a, it's going to take that base 10. So it's calculating 10 to the power of x is equal to a, and it's solving for what that exponent is. Yeah, so if we plugged log 100 into the calculator, it's going to solve 10 to the power of what is equal to 100, and then it's going to tell us that the answer is 2.
Let's just do some examples.
To be clear, and I'm just going to be straightforward with this, the calculator actually can calculate logs with different bases. I'm not going to show you how to do that right now. I will probably eventually show you, but it can do it, but it's a little clunky, which is why converting to base 10 is actually helpful, because there is a direct button for base 10. So we're going to use the calculator to do this part. So if we're converting this to be log base 10, this is going to be log of A, 64, over log of B, meaning the base, which was 16. So we have in the calculator the log button, 64, divided by the log button, 16.
You get 1.5.
And that gives us 1.5. By the way, to be clear, we do have to hit the close parentheses button when you're typing these in. So don't just type log 16, or sorry, log 64 divided by log 16 as is. You need to close the parentheses. So part B, we'd have log of what over log of what? Log on top, what's the first one? 54. And then this one would be 2. And when we type that into our calculator, what do we get?
We get
5.7? 5.75. Okay.
No, I got 5.75.
Oh, okay.
Send them. No. Send it to me.
Okay. So now we have some properties of logarithms, and we have lots of examples to go with these. So the properties of logarithms. We use these to condense and expand logarithms to help in solving. Yeah. Okay. So the product property, the log base b of m times n is equal to log base b of m plus log base b of n.
So it's just like exponents. When multiply, you add.
Mm-hmm.
Okay. And then for the exponents,
That's it for the quotient.
So for the quotient, we subtract log base b of m minus log base b of n. And then if we have a power, we put n on the front times log base b of m. So yeah, it's just like exponents. That's the pattern.
because the logs does use an
Mm-hmm. Well, they technically just are exponents. It's just a,
They are.
So
Yeah.
they need to have the same base.
yes.
Is there also a
You have to have a
specific
common
log?
base.
You do. I know you can do log. There's a log base too.
There is, I'm not going to show you how to do that part right now, because you need to be able to know how to do this stuff, and if you're just plugging in the base, it's not going to help you.
I found it.
Example 5, condense into a single logarithm. Simplify if possible. So we have log base 2 of 7 plus log base 2 of 4. Because they have the same base, and we're adding, then that means that we can rewrite this as log base 2 of 7 times 4, which means that our answer is log base 2 of 28.
It doesn't have a base.
We could solve it. For now, this is all we're doing.
Okay. For the sake of time.
Yep. Okay. So we have the next one. Log base 10, because it's a common log, plus log, again, base 10, common log. There's no base written. That's what it means. So then we have a 4. Log of 25 times 4, which is equal to 100.
So it's just be log.
Mm-hmm.
Does that mean you can't add them together unless the base
It has to be the same.
They have to have a common base. Yep. Correct. Yep. So this one, we have the common base of 4. And then we have 2x and 4x squared that we're going to multiply together. So we have 2 times 4 is 8. X times x to the power of 2 is equal to x cubed. Okay. Log base 4. Sorry. Okay. Example 6. We are going kind of back the other way because we're going to expand this using the product property. So the question here is, what factors of 6 do we know? 2 and 3. So we have log of 2 plus log of 3. Is that the only possible solution here? No. Because we could also use 1 and 6. So an important note to make, that your answers may vary.
We should just do like 2, 3. You don't get answers very often.
That's true. We can write down the other option here.
Just do 2, 3.
So you could have log of 1 plus log of 6. You could have that. All right. B, we have log base 7 of 45. What factors do we know of 45? 5 and 9. So we have log of 7. No, but I tend to. Log base 7 of 5 plus log base 7 of 9. You could also use 3 and 15. All right. Then last one, we have log base 2 of 5x. We could write that as log base 2 of, what's one factor? 5. Plus log base 2 of, what's the other factor? X. What's the only other way we could write that? 5x and 1. I guess there's probably other ways, but with what we're doing right now, that's what we're looking at. Yeah. But sometimes more complicated is not necessarily better. Example 7. Condense into a single logarithm. Simplify if possible. So when we're subtracting, what do we do there?
Divide?
Divide. So log base 3 of 24 over the one that we're subtracting, 8. And again, you need a common base. Can we simplify this?
Yes.
Yeah.
Log base 3 is 3.
Log base 3 of 3. Because 24 divided by 8 is 3. All right. Part B. We have log base 2 of 15 minus log base 2 of 15. So that would be, yes, log base 2 of 1, because 15 divided by 15 is equal to 1.
That does equal 0.
Yes.
Wait, but we're right on 0.
Yeah. We're not really solving at the moment, but if I asked you to solve them from here, which we will eventually, that is what you would do.
How would it be 0?
Are we? Because this means base 2 to what exponent is equal to the answer 1. So if we were solving it, x would be 0.
So whenever it's a 1, it's always 0.
Whenever it's a 1, it would be 0, yes.
And if there is
Unless
no
it's
like
0.
base, then it's
Correct. If there is no base, it is a base of 10. All right. Yes. Because the common log is 10, so if it's 1, you have to put the 1. So we have log base 4 of x minus 9 minus log base 4 of x to the power of 2. So we have log base 4 of x to the power of 9 over x to the power of 2, which I already heard simplifies down to log base 4 of x to the power of 7. Why does it simplify from this to that? Because the exponents are dividing, and when you divide an exponent, you subtract the exponent. By the way, in case you were wondering, the answers do not vary on this slide. I just left it up there because they will vary on this one. So on this one, we are expanding using the quotient property. So I'm trying to get to a point where I have some subtraction happening. So I have log base 8 of something minus log base 8 of something. These two things, when you divide them, need to equal 4. Isaac? 8 and 2. Because 8 divided by 2 is 4. You could also do 16 and 4. You could also do 28 and 7. There's lots of options on these. All right, B, we have log base 5 of 1/3. And we're trying to subtract because we're dividing. So what divided by what is equal to 1/3? 1 divided by 3. Is there anything else that we could put in there? You could do 3 minus log base 5 of 3 minus log base 5 of 9. 2, 6. Lots of options. Then we have C, log common base. So that's just log of what minus log of what? So something divided by something to equal m over 7. M and 7. Log of m minus the log of 7. All right, example 9. We're going to condense into a single logarithm and then simplify if possible. I'm going to get rid of the answers may vary thing now. All right, so looking at option A here, we have 5 times log base 4 of 2. And when we have something multiplied out front, what does that mean for us? It's the exponent of this. So we'd have log base 4 of 2 to the power of 5. What is 2 to the power of 5? 32. So we have log base 4 of 32. Okay, but we don't need that, but yes. All right, B, we have 7 times log base 2 of x. That'd be log base 2 of x to the power of 7. And there's nothing we can do to simplify that right now. Then this one, we have 1/3 times log of 8. So then we have log of 8 to the power of 1/3, which is the same as a cube root of 8. So that simplifies down to the log of 2.
It's just a
Cube root of 8, yep. Example 10. Expand using the power property. Simplify if possible. So we have log base 2 of 8 to the power of 7. What can we do with this exponent? Take it out and put it in front. So we have 7 times log base 2 of 8. So B, we have 3 times log of 4 to the power of x minus 1. What can we do with this exponent? Put it in the front. So we have 3 times x minus 1 times the log of 4. 3 times x, 3 times -1, so we have 3x minus 1 times, oh, you're right, minus 3 times the log of 4. And that, for right now, is as far as we are going. Log base 7 of the square root of w. Log base 7 of w would be to what exponent then? 1/2. So then we can take that 1/2, set it out front. So we have 1/2 times the log of, log base 7 of w. And that's all we're doing with it. It does get ugly. We'll just take it one step at a time. Okay, let's start with A. We have log base 10 of x. What can we do with this to simplify it? You can take out the 10 because it's a common log. Did I? Oh, well. Do you have the rest of them?
Yeah, we have the rest of them.
Okay, well, all you'd have to do on this one is just take out the 10. So that one's kind of easy. Apparently, I gave you guys a different question than is.
Put 7 log base 4 of u minus 3 log 4 base v squared. Wait, sorry, log base 4 of v squared.
Well, that's the better one. We should be doing that one, but we will come back to that one. Let's go to B. We have log base 2 of 15 plus log base 2 of 4 minus log base 2 of 6. We're going to follow like order of operations going from left to right. So we have log base 2 of 15 plus the log base 2 of 4. What do you do when you're adding? Multiply. So we log base 2 of 15 times 4, which is 60, and I'll write that on the next one. Minus log base 2 of 6. What happens when you subtract? Division. So we have log base 2 of 15 times 4, which is 60, divided by 6, which means that we really have log base 2 of 10. Okay. Part C. We have log base 7 of q to the power of 4 times r to the power of 2 all squared. We don't need to break down a whole number that's in here. So then here we have log base 7. What are we going to do with this exponent? I already read the whole thing. Put it in the front. So we have 2 times the log base 7 of q to the power of 4. What happens when we multiply in here?
Division.
We add. Here's now the question. If we put the 2 out here and we multiply by this whole thing, now we're splitting it to have addition. Does this second one also get a 2 out front? Yes, it does. So we have 2 times the log of 7 times r squared. We are trying to get it in as simplified form here, but we're not done. We're trying to get like one single number inside the parentheses, if at all possible. So if we are looking at those, what else can we do here?
With the exponents now that are on r, so you can put the 4 up front. Base 7 of base 7. 4 log base 7.
Okay, so we took the exponent and we put it out front, and we're going to do the same thing over here. 2 times this 2 from the exponent times log base 7 of r. So this simplifies down to 8 log base 7 of q plus 4 log base 7 of r. So yes, it is bigger, it's expanded out, but it is simplified because we no longer have any exponents inside of our answer. We just have that q and the r.
The first time I've seen it simplifying, not really be simplified. It doesn't look simplified.
You're right. It doesn't look simplified.
Like it's harder on the eye.
It looks crazier. But in terms of something that would be more solvable, that is nicer. So then we have log base 3 of the fourth root of m to the power of 5 times n to the power of 2. So we're going to, first off, if we have a fourth root, what does that mean is happening in here? We're raising all of this to the 1/4 power. So we can take that 1/4 power and set it out front as multiplication. So I have 1/4 times log base 3 of m to the power of 5 times n to the power of 2. I'm breaking this one down a little further. Okay. So now we're going to split our multiplication up. So we have 1/4 times log base 3 of m to the power of 5 plus, do we get a 1/4? Yes, we do. So we have 1/4 times log base 3 of n to the power of 2. Can we go any further?
Yes.
Yes, we can. We're going to take this 5 and multiply it out front. So we have 5 times 1/4. We're just going to leave that as 5/4 times log base 3 of m plus 2 is going to come out front. 2 times 1/4 is equal to 1/2. 1/2 times log base 3 of n. And this would be our final simplified form. So if we're doing E, notice that we have this extra set of parentheses. So 1/3 is multiplied by this together. So we need to combine these things first. Log base 5 of 8 plus log base 5 of 27. How can we simplify these? Yeah.
So you could take 8.
We're not going that route.
Nope.
So we don't need to change a whole number.
Multiply.
We're just going to multiply them. So we have log base 5 of, can someone type in that for me? 27 times 8?
It's 216.
216? 216 or okay. 216. Okay. Minus log base 5 of 3. So this 1/3 is multiplied by that first part, which means that we are taking this 1/3 because we have to combine these, and right now we can't. So this 1/3, we can set that to the power of, we can put it back as the exponent of 216. So I have log base 5 of 216 to the 1/3 power minus log base 5 of 3. If this did not simplify nicely, we wouldn't do it. We would just leave it like this. But this is going to work nicely because what is the cube root of 216? 6. So we have log base 5 of 6 minus log base 5 of 3. Can this simplify? 6 divided by 3 gives us that log base 5 of 2 is our most simplified version because 6 divided by 3 is 2.
That was satisfying.
That is all. It all simplifies down to log base 5 of 2. So if we're looking at F, we have log base 2 of y over z to the power of 5, all raised to the power of 2. So we're going to take that exponent and set it out front. So we have 2 times log base 2 of y over z to the 5th. Can we simplify this down? Yes. Because it's division, so we're going to separate it using subtraction. So I have 2 times log base 2 of y minus 2 times log base 2 of z to the power of 5. So we're going to take that exponent and set it out front. So we have 2 times the log base 2 of y carrying through minus 2 times 5 is 10 times log base 2 of z. Can that simplify any further beyond that? No. So that is our simplified form.
And that is where we're going to stop today.